Hello everyone. Thank you very much for watching this video, and I welcome you to my YouTube channel, Dr. K's Classroom. So in this short video, I'm gonna uh, briefly talk about the key concepts that you need to know in order to succeed AP Physics 1. So in my classes, I reiterate, I emphasize these key concepts all the time to my students and use these concepts to solve complicated problems. Okay. And if you join my video series, you can watch the video series in my YouTube channel. You will, understand these concepts and see some problems where we apply these concepts. So right away, I'll just go into discussing, briefly discussing or talk about these concepts. So the first one that you need to know, the first concepts, that's kinematic equations. Okay, one dimensional, so I'll write 1D kinematic equations. So these equations basically describe motion. They describe motion. There are three equations that you should know. Okay, so I'm going to write them down, and later in my lecture series, you will see like I'm going to dive deeper into these concepts, these equations, and explain them. But right now, this is just stating the key concepts that you need to master for AP Physics 1. So, number one dimensional kinematics equation. So, these are the equations. So, this is V final, that is velocity final, equals velocity initial. Sometimes you will see like V, instead of V sub I for initial, you'll see V sub 0. That's like initial, right? T equals 0, that at that moment. V initial, but I'll use subscript I for initial. V initial plus A, that is acceleration, and T for time. And then we have another equation, uh, x final minus x initial equals v initial t plus 1 half a t squared. Now, the x final, that's the final position of the object or the particle. X initial, that's the initial position of the particle. Okay. V initial, that's the initial velocity of the particle. And the others, like, I introduced those in the first equation. Then the third equation, V final squared equals V initial squared plus 2 times the acceleration A, x final minus x initial. Okay. So these are the three kinematic equations that you need to know in order to succeed in AP Physics. So this is concept number one, you should know. Concept number two, Newton's laws. Okay, Newton's laws. Again, just like concept one, there are three equations that you should know. The first one is called law of inertia. Law of inertia. Okay, so that's where we talk about, like, in the absence of a net force, net external force acting on an object, the object either remains at rest or moves with a constant velocity, right? So, in other words, I'll write this happens when the sum of the total forces is equal to 0. Okay, that's like law of inertia. When the sum of forces equal to 0, uh, either the object is at rest or the object moves with a constant velocity. constant velocity. So as you can see, I'm just stating these key concepts so that you prepare yourself when you study AP Physics 1, you will understand, okay, these are the concepts that you really need to know in order to succeed in this course. Okay. And then I told you, like, there are three laws, right, for Newton's laws. Then the second one is law of acceleration. Law of acceleration states what happens when the net external force is not equal to zero. When the net external force is not equal to zero, um, it's basically equals to mass of the object times the acceleration of the object. Okay. First one talks about when the net force is zero. Object is at rest or moves with a constant velocity. The second equation talks about what happens when the net force is not equal to zero. The object accelerates, it changes velocity. So these Newton's laws basically, talk about what causes motion. What causes motion? Kinematic equations, they talk about, like, they're describing motion. They're going to describe motion. And the third one, sometimes I have seen it's called law of interaction. Okay. In other words, like, for every action force, there's an equal and opposite reaction force acting on a different object. Action and reaction pair. I'll just write that. Reaction pair. Okay. So that means for every action force, there's an equal and opposite reaction force acting on another object. So let's say this is the action force. We can represent a force by an arrow. So let's say this is action force. Then on another object, there's an equal and an opposite reaction force. Let's call that F double prime, like that. Okay, so that's law of interaction, or in other words, for every action force, there's an equal and opposite reaction force. So Newton's law, one of the main pillars that you need to know in AP Physics 1. Okay, so let's talk about the other concepts now. Number 3, conservation of mechanical energy. As you know, just like motion, energy is a very important concept in physics. Conservation of mechanical energy. Okay. In the absence of uh, external resistive forces, the total mechanical energy of a system does not change. It does not change. So that's what we call conservation of mechanical energy. If the mechanical energy of a system is changing, then there's work done by a frictional force, a resistive force. Okay, so that's how we are going to apply conservation of mechanical energy. If there are no external resistive forces, sometimes they are called non-conservative forces applied on a system. If there are no non-conservative forces, mechanical energy of the system does not change. If there are non-conservative forces acting on the system, mechanical energy will change. Number 4, concept number 4 that you need to know, conservation of linear momentum. Conservation of linear momentum. This is again something very important, conservation of linear momentum. If there's no net external force acting on a system, it's linear momentum, mass times velocity, okay? It's called mass times velocity, linear momentum, does not change. It does not change. Number 5, and this is the last concept that you need to know, conservation of angular momentum. Conservation of angular momentum. So, in the absence of a net external torque acting on a system about an axis of rotation, the angular momentum of that system does not change. Okay, does not change. So, from my experience of teaching AP Physics 1, this is what I have realized. If you know these 5 concepts, if you know how to apply these concepts to solving problems, you are really good, right? I believe that you have mastered AP Physics 1 if you understand and you know how to apply these concepts to solve problems. So in my next video, and the videos that are going to be posted soon, I will be talking about AP Physics 1. I'll be going through like concepts, doing example problems, doing worksheets, and all that. So join my YouTube channel, like and subscribe because I'll be posting new videos regularly for AP Physics 1. Okay then, thank you very much and have a great day. Bye now.